Geometry 7-6, similarity transformations. So before we get started on this one, I want you to see if you can, get some graph paper to use, because we're going to be using the coordinate plane. It's going to be way easier if you have some kind of graph paper. We have some available at school. Otherwise, if you have some at home, it's going to make this quite a bit easier, this lesson. All right. Now, remember, so we did a little bit of transformations already. And you might have a triangle like this. And if I were to draw a line coming out like this, like that, and then we have another triangle coming like this. We've made a transformation here. The first one is the pre-image. So that's the one that we started with. And the second one is the image. That's where we finished. Okay, and what we've done here in this example is a dilation. Dilation just means that we're scaling it. It's a transformation. That proportionally enlarges. Proportionally enlarges or reduces the original. So it makes it bigger or smaller. And it is a similarity transformation, meaning that the image and the pre-image are similar. All of the angles are congruent, and all of the sides are, corresponding sides are congruent. I mean, not congruent, proportional. Corresponding angles are congruent. Corresponding sides are proportional. That is what we mean by similarity. Okay, we've got dilation. We've got another term we need to know, and that is the center of dilation. This is the point from which dilation occurs. So, if I were to have a coordinate plane like this, and I have a little rectangle here, and I have my center of dilation over here. So here's my center of dilation. Then I would draw a line that goes through that point and extends through that point and extends through that point and extends through that point and extends. And so my if I were to do my dilation, I would have, well, this goes to the second one, down to the second one. There we go. Oops, first. There we go. Here's my center of dilation. That's the point from which the dilation occurs. It could also look something like this. If I have a rectangle this way, and my center of dilation is like, say, over here in the corner, so there's another one right here. Boop. I could have the center of dilation inside my object or shape, and then I would draw my lines out, and then I would draw my shape. There we go. So that's center of dilation. One more term, and that is scale factor. and this is one that we have already looked at, but we're going to talk about it a little bit more. This is the ratio of corresponding parts. So it's the image over the pre-image. So the scale factor, it will be an enlargement if the scale factor is greater than 1. So we're going to say K as the scale factor here. It'll be a reduction if the scale factor is between 0 and 1, meaning it's a fraction that is between 0 and 1. So let's do some examples of scale factors here. Tell me what is the scale factor between these two numbers? So for A, we have 6, and for B, we have 3. So A is the pre-image, B is the image. So the image we put on top of the pre-image. And so we have 1/2. So we have a reduction. The scale factor is 1/2, and it is a reduction. Let's do another one. A is 12. B, oh, am I doing something? Oh, yes. Okay. This next one we're going to do on the graph paper. Okay. So I have on my graph paper, and then we're going to kind of be switching back and forth between the graph paper and the non-graph paper for a bit. So we're going to do a U-try here. And it is going to be, I'm going to start with this triangle here at 1, 1, 1, -1, and 2, -1. Here's my triangle. And then, so this is my image. Now my pre-image here is at 3, 3, 3, -3, and 6, -3. So this is my pre-image. Okay, so now let's look at this and let's see if we can figure out what the scale factor is here. So what I'm going to do is I am going to count one of these sides and see, and then I'm going to count the corresponding side and find my scale factor that way. And so let's go ahead and let's pick this side here, and the corresponding side here is this one. So my pre-image is the one that goes on top. So 1, 2, 3, 4, 5, 6. So 6 goes on top. That's the pre-image. And then 1, 2 is the image. Oh no, did I say the pre-image goes on top? Sorry, the pre-image goes on bottom. Pre-image goes on bottom. Pre-image goes on bottom. image goes on top. So the pre-image is 6, image is on top, which is 1, 2. And so we have a scale factor of 1/3. So it started with this big one and then went down to the small one. It scaled down or dilated down. It is a reduction of 1/3. Okay, now let's do another bit of notes, and then we are going to go back to this. So we're going to go to our piece of paper, and then we're going to do a little bit more graph work. Okay, and so here's our piece of paper. Oh, are we not? Oh, we're just gonna stay on this for the rest of the time, except for a little bit of work that we're gonna do. Sorry. Here we go. We're going to graph a rectangle now. So this rectangle is going to be at -2, 1, -3, 2, 4, 1, and 3, 4. All right, now let's connect these guys. I'm saying this is a rectangle, but I don't know for sure if it's a rectangle. It just looks like one. Okay, now this is the pre-image. And now the image is going to be at -4, -2, 6, 4. I'm sorry, -6, 4. And then, let's see, +6, +8, and 8, 2. And then I'm going to connect all of these guys. Okay, this is the pre-image, and the big one is the image. Okay, now we want to know what is the scale factor between these two. There are two ways to go about doing this. There's an easy way and there's a hard way. Now the easy way is only going to work on specific problems like this. And then there's the harder way that's going to work with every problem. So let's look at the easy way first, and then let's look at the harder way. So this one I know is going to work the easy way because I can count over. Here's the easy way. I count over 1 to the left and then up 3. Notice that? Now, on the larger one, on the image, I go over 1 and then up 3. And then I go over 1 and I go up 3 again. Notice how I've gone to the left 1 and up 3 once on this one. And I did the same exact thing twice on this one, with nothing left over, nothing skipped, whatever. So I know that this is the same length as this right here, is the same length as this right here. So I know that the image is twice as big as the pre-image. So I know the scale factor is 2. But you're not always able to count like that and see that. And sometimes, it's not going to be that easy. So that's the easy way. Let me show you how to do it the way that's going to help you if you can't see that and you can't count it that way. So what I'm going to do is I'm going to use these 2 points, or these 4 points, and I need to find the distance between these two and the distance between these two and compare those. And so for the pre-image, I have 4, 1 and 3, 4. So I need to find that distance. And then on the image, I'm going to do the corresponding side, which is 8, 2, and 6, 8. So I need to find the distance between these points and the distance between these points. We're going to do it kind of quickly, hopefully, so that we can move on and be done with this. So x1, y1, x2, y2. Remember, the distance formula is the square root of x2 plus x1 squared, no, x2 minus x1 squared plus y2 minus y1 squared. Sorry, should be minus in there. Okay. So the distance of the section of the pre-image is going to be distance equals the square root of x2 minus x1, so 3 minus 4 squared, plus y2, 4 minus 1 squared. 3 minus 4, 4 minus 1. All right, I'm going to set up the next one too. x1, y1, x2, y2, 6 minus 8 squared plus 8 minus 2 squared. Okay, 6 minus 8, 8 minus 2. All right, 3 minus 4 is negative 1 squared plus 4 minus 2 is 3 squared. Remember, that's in the square root sign. So the square root of negative 1 squared is 1 plus 9. So I've got the square root of 10. Okay, I don't need to do anything with that. I'm just going to leave it for right now. 6 minus 8 is negative 2, so negative 2 squared plus 6 squared. So that's 4 plus 36, so that is the square root of 40. That is pretty gross. We know that the scale factor is 2. Okay, so I am going to end up putting these in the calculator. So I'm going to take the square root of 10. That is approximately 3.16, and the square root of 40 is approximately 6.32 ... So notice how let's take the image and the pre-image and put them on top of each other the right way. So remember, the pre-image goes on the bottom, and so the pre-image was this 3.16, and the image is 6.32. If I divide those two, I get 2. My scale factor is 2. So if you can do it the easy way, it's way easier. But you can do it the harder way as well, and you should still get the same answer. Now, if I was to, I could avoid the calculator by saying this is 2 times the square root of 10. And you can see 2 times the square root of 10 over the square root of 10 is 2. So I can get my scale factor of 2 that way as well. All right. Whew, goodness, gross. That was some crazy example. Okay. Now let's do another couple examples here. Let's see if these two triangles are similar. So I've got a point at 0, 1, 3, 0, and 2, 3. So there is my triangle. And then I have another triangle at 0, 2, at 4, 6, and 7, 0. Okay, now this one I highly suggest you use some method that's going to be a little bit easier than what you might need to do if you don't use an easier method. So I'm going to do a lot of counting on this and trying to figure this out. that way, because I don't want to find the distance between these 2 points and these 2 points, these 2 points and these 2 points and these 2 points and these 2 points. I've got to do the distance formula 6 times. I don't want to do that. But that is one way to be sure whether or not these are similar. You do the distance formula for each side, and you set them up as proportions. And if they're all equal, if they're all equivalent proportions or equivalent ratios, then you're good. These are similar. And if not, if any of them are off, then they're not similar. Okay, so that's kind of the long way, but it works. Now here is a way that might be a little bit easier. So we're going to count. So on this bigger one, I'm going to go up 2 to the right 2. Okay, up 2 to the right 2. Now I'm going to look at this corresponding side. Up 1 to the right 1, up 1 to the right 1. Okay, so these sides are the scale factor of 2. And so we're pretty good here, and they're the same slope. Up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, right up. Okay. Now, let's try this other one here. This is to the right 1 and then down 3. Okay, to the right 1, down 3, to the right 1, down 3, to the right 1 again. Okay, so these two don't have the same slope. Let's see if these ones do. Down 1 to the right 3, down 1 to the right 4, down 1 to the right 3. Okay. So let's see, that should be right there. So these do not have the same slope either. So that means if these are parallel and these ones are not parallel, then we have a problem. These are not similar. And now the slopes don't necessarily need to be the same if two shapes are similar. Not necessarily. But in this case, if these ones are the same, then these ones need to be the same as well. Or they need to be opposites of one another. Anyway, these are not similar. Unless they are. No, they're not. They're not. Okay. Now we've got another one that we're going to look at. This is the last one. Find out if these are similar. And if they are, I want to know the scale factor. Okay, here's the last one. We've got two triangles. -1, +1. 1, 0, and 2, 2. Here's our little triangle. Now I've got 4, 0, 2, -4, and -2, -2. Okay, now we need to decide, are they similar? Yes or no? And what is the scale factor if they are? So go. All right, let's see how you did. Okay, so this little guy here is the I didn't even tell you which one was the pre-image, sorry. This is the pre-image, and this is the image. Okay, now I'm going to count these and see if they're in proportion to one another. So I go up 1 to the right 3. Okay, up 1 to the right 3, up 1 to the right 3. Okay, so these are the same slope. Now I go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. Okay, these are the same slope. Now let's check these ones out. Over 1, up 1. Over 1, I'm up 2, sorry. Over 1, up 2, over 1, up 2. Okay, so these are all the same slope. All the corresponding sides have the same slope. Yes, they're similar. And if this is the pre-image and this is the image, I've noticed, see, this one has up 1 to the right 3 once, this has up 1 to the right 3 twice. Same thing with these ones, twice, and so the scale factor is 2. Now, you could list the points, and you could set up a, you could find the distance between these two and the distance between these two, and find the scale factor that way, and you should still find 2. Either way, you should end up with a scale factor of 2. All right, kind of a messy one here, but there it is. And good luck on the homework. This was the last section of Chapter 7.